Okay, so today we're going to cover lesson 1-2 and probably at least try to start 1-3. So the first thing we're seeing here is what a grouping symbol is. And a grouping symbol could be a parentheses, it could be a bracket. And we're also going to see that when you have a problem that's written as a fraction, think of the numerator and the denominator as a grouping symbol. So the parentheses should always be simplified first. And we're going to do the 5 minus 3 first. And then we're going to multiply it by the 6. Okay, now notice on example B there, the 5's in parentheses. Now again, yesterday I told you that a lot of times we're not going to see the X to represent multiplication. We're going to either see it with a dot or we'll see it separated next to each other with parentheses. So these are going to indicate multiplication. So on example 1, part B, I'm going to multiply 6 times 5 first, and then I'll subtract the 3. Everybody good on these? All right, now another way to see a grouping symbol is you could see it as a fraction. So again, think of doing the whole numerator on this problem first, and then evaluate the denominator, and then we can simplify our fraction. So can anybody tell me what I need to do to simplify the numerator of example 2? Yes?
First, you need to add 12 plus 4.
And you get?
16.
Okay. And then what's your next step?
15 minus 7, which is 8.
Okay, and now what do I do?
And now, divide by 8, that makes 2 wholes or 2.
Perfect. All right, now throughout this course, you should always try to simplify your improper fractions if possible. Sometimes I'm going to let you leave them improper, but if it will ever simplify to a whole number, you do have to do the division. All right, so in some instances, I will let you leave them improper. Other times, I'm going to either have you make it into a mixed number or a decimal. And as we encounter those, I'll show you those examples. So again, here are different types of grouping symbols. The first one is parentheses. These are brackets. And then a fraction bar. These are all examples of grouping symbols. And go ahead, question?
Why would one need brackets as opposed to parentheses? Because those two expressions, they look the same.
Okay, so generally when you're going to see brackets, you're going to have a parentheses within them. So notice here in the italicized print, notice it says here, first simplify the expression in the innermost grouping symbol. So more than likely when you're going to see brackets, you're going to have something like this. You'll have, say, a 2. Let me put the pencil on. You might have a 2, a bracket, and then maybe there'll be a 3, and then a parentheses, and then maybe 5 minus 2, and then a closed bracket. So generally when you have parentheses already in the problem, to introduce another grouping symbol, that's when you're going to see the bracket. So I think the reason why they just wrote the exact same problem there, just to show you what a bracket looks like. So a parentheses, they're curved. Brackets have like squared sides. Okay, that's the difference. And then just the fraction bar. So whenever you've got a fraction, you're going to simplify the numerator, simplify the denominator, and then if possible, simplify the fraction if necessary. Good so far? Yes. All right. All right, so again, have you guys seen this little acronym, PEMDAS?
Yes.
Okay, so for those of you who haven't, the P represents the parentheses or the grouping symbol. The E represents exponents. The M and the D represent multiplication and division. And then the A and the S represent adding and subtracting. Now, remember that the M and the D and the A and the S, those are equal. So it doesn't necessarily mean that multiplication comes before division. You're just going to look for the first multiplication or the division that comes in the problem and work left to right. So just like I'm reading the words on the page there that say, when there are no grouping symbols, notice I'm reading from the left side of the paper to the right side. So you're going to do the same thing when you're solving the math problem. After you figure out, is there any parentheses to do first? Then if there's no parentheses, then you're going to try the exponents. And then when you get to that M, if there's a division before the M, you do that first. Everybody make sense? All right, so let's try example 1 here, or 3, sorry. All right, what do I need to do first? I've got 2 sets of grouping symbols there.
Add 7 plus 6.
Perfect. You're going to do the innermost grouping symbols first. So I'm going to add 7 plus 6. What do I get?
13.
Good. All right, now, what I like to do is I like to rewrite my problem here. So I'm going to drop down the 18. I'm going to drop down my bracket and 152, and then divide by 13. All right, I don't need to keep the 13 in parentheses. I can just leave. I know. Let me space it out. Yeah, it's 52. Let me space it out better. All right, so bracket 52 divide 13. And I can even now turn those brackets into parentheses because I've only got 1 set there. All right, so then 52 divided by 13.
4.
Okay, and if you're not sure, just quick do it over on the side. So then 18, so then I have to do the next grouping symbol, which are the brackets. So 18 minus 4, and 18 minus 4 is?
14.
And I'm done. Okay, so again, when there are no more grouping symbols, we're going to simplify. So here they've left out exponents, but that would be the next thing, and I know we haven't covered exponents, so that's why they're not putting it in our PEMDAS. But then you're going to always do the multiplication division in order from left to right, and then after that, you're going to do all the addition and subtraction in order from left to right. Let's try example 4. So 4A. What do I need to do first?
Multiply 15 and 4.
Okay, and what do you get when you multiply 15 and 4? 60. All right, so again, I'm going to rewrite my 29 and my plus sign. And now what do? Add that up, right? And what do you get when you add 29 plus 60?
89.
Perfect. All right, next one, part B. What do I need to do first here?
Multiply 12 times 2.
Perfect. Okay, so we're going to multiply the 12 times 2 first. So I'm going to rewrite the 19 minus 7, put the plus sign. I'm going to multiply the 12 times 2. Then I'm going to drop down my division and my 8. Okay, what's my second step?
Divide 24 by 8.
And you get? Okay, again, I'm rewriting stuff. All right, now what do? Does the adding or the subtracting come first? Perfect. Okay, remember adding and subtracting, even though in our little rhyme here or our little acronym, even though the A's first, it says here we work left to right. So we're going to subtract first. So 19 minus 7 is?
12.
Okay, then I'm going to drop down the plus 3. And then finally, last step, I will add the 2 numbers. If you're doing these, you need to do it step by step. Don't try to rush through it because chances are you might make a careless mistake. All right, the next one. We've got a fraction here, and it's got some numbers and some variables. So it wants us to evaluate. They're giving us the information. They're telling us what x equals and what y equals. So the first thing I'm going to do is I'm going to replace my letters with what they told me that they equal. So I'm going to rewrite my problem. So I'm going to do 4, and to show the multiplication, I'm going to put it in a parentheses. You can also put a dot in between it, just don't put another x in there to represent multiplication. So then I'll have 5 times, and if you'd rather write it as a dot, you can do it that way also. So you can represent the multiplication either way. Everybody good on this? Okay. A lot of times what you're going to see it as, you're going to be seeing as written as parentheses. Okay, so then here on the bottom, I'm going to put 3 times 3 minus 8. So now I've got to begin simplifying. So first thing I'm going to do is simplify each thing separately. So first I could work on the numerator, and then I could work on the denominator. So what do I need to do first in that numerator?
4 times 3.
And what do you get?
12.
Okay, what else can you do?
5 times 8.
And you get?
40.
Okay, and then if you want, you could show the multiplication on the bottom also. And then now in the next step, you could show the addition and the subtraction. What's 12 plus 40? Okay, and what's 9 minus 8?
1.
All right, and then notice anything divided by 1, and this is going to simplify to 52. Pretty good so far? Am I going too fast? All right. All right, so for the oral exercises, it's asking us to describe what operation is being done for each example. So notice in the sample here, it's got a 3, it's got a grouping symbol with x plus 1 in it, and then a plus 5. So notice how the solution here, first thing they're telling you to do is multiply 3 by the sum of x and 1, and then you would add 5 to the product. And then here it's saying add x and 1, multiply by the sum. Those are two different solutions you could do. So it's not asking you to solve anything here. So on number 1, when you have a number next to a letter, what operation is in between these two? Are we adding, subtracting, multiplying, or dividing? Multiply. So you would say, you would use, the operation would be multiplication. On number 3, what's going on there? What kind of operations we got?
Multiplication and addition.
Perfect. So the 9 and the x are being multiplied, and then the sign in between the 9x and the 4 is addition. Perfect. What about on number 4? What operations?
Multiplication and subtraction.
Perfect. Okay, what about number 5?
Addition and multiplication.
Good. So when you have a number outside of that grouping symbol, you're going to know that you're going to multiply the 4 to it, and then inside the grouping symbol was addition. Perfect. All right, what about number 7?
Division and addition.
Perfect. Whenever it's a fraction, remember that fraction bar means division. All right, and then number 9?
Division and subtraction.
Perfect. Everybody good on those? All right, let's practice evaluating. So now they want us to go back, and let's just do like 2 of them. So if I were to evaluate number 1 now, and they told me that y is equal to 3, what would I get when I substitute the value of 3 for my y?
21.
Good. So you're going to do 7 times 3, and you would get 21. All right, let's try and do number 7. Let's evaluate that one. So it's a z over x plus y. So again, I'm using the same values. So my z is a 7, my x is 1, and my y is 3. God bless you. What do we do here? What do we do first, now that I plugged everything in? Yes.
Add 1 plus 2.
Okay, and you get?
4.
Okay, now this is the situation where I'm okay with you leaving it like that. Okay, I know you're probably tempted to make it a mixed number. I'll specify when I want a mixed number or a decimal, but I'm okay with you leaving it like that. Okay, now I know you're probably not used to it. If you go ahead and make it a mixed number, 4 goes into 7 once, 3 left over, so that's also equivalent to 1 3/4 or 1.75. but I'm okay with you leaving your answer like that. All right, let's go on. So everybody's already taken a picture of the homework. Again, the homework tonight for lesson 1-2 is 1 through 33 all. Okay, so you'll do that for homework tonight. But I'm going to go ahead and introduce lesson 1-3 today. So let's. All right, so in lesson 1-3, we're going to be having equations here. Now, have you ever heard of the word domain? Yes. Okay, and can you explain to me what domain is?
Well, the domain is basically the possible value of the variable.
Okay, good. So it's your input value. All of the values that the variable could be. So in this case, they're going to give us a domain, and they're going to ask us to find out which one is the true answer. Okay, so right now, they're not officially teaching you how to solve equations, and I know you've probably seen it in middle school, but what they want you to do in this is to take each one of the numbers in this domain, and you're going to replace the value, you're going to replace the variable x, and you're going to do the problem until you find the one that works. So for example, if I take my equation, 5x minus 1 equals 9, I'm going to take out the letter x. The first time I do it, I'm going to replace it with the number 1. So 5 times 1 minus 1, and I need to see if when I do that left side, if it equals 9. So 5 times 1 is 5, minus 1 is, not 6, it's 4. Does 4 equal 9? No. So the number that they're asking me to try, the number 1, it doesn't work. So that one's false. Now I'm going to try it, replacing x with the number 2. So 5 times 2 minus 1, let's see if it equals 9. 5 times 2 is 10, minus 1. 10 minus 1 is 9. That one works. So it's true, yes.
But for equations where there's a wider range, is there no more efficient way to do it than just guess and check?
Okay, we're going to learn how to solve equations by working backwards of PEMDAS. So what we would do, normally, this is called a two-step equation. And what we would do first is add the 1 and then divide by 5. So yes, there is a more efficient way, but if they're asking you to show the work and how you're going to plug in each one of the domain values, I know it's, it's going to take a little bit of time and it's a lot of work, but it's easy math. Does that make sense? But yes, we are going to learn a more efficient way of finding the value of x. Okay, then obviously if we've already found the value of x, which is going to be 2, we'll just quick try for 3. So we're going to put 3 in here. And then 15 minus 1. And we get 14. And this is also false. So when they're giving you a set domain, they're going to want you to show how you're going to replace each one until you find the one that works. But again, we are going to learn a more efficient way. So for this problem, our solution set would be x equals 2. And then you're going to write the squiggly parentheses or the, those are the set operators. So it's like squiggly looking parentheses. And if you look right here, here is their set operators. So that's how you could write your solution set. Some textbooks would just have you say x is equal to 2. So any way to indicate the solution that works. So once we're finding the solution set, that process is called solving. Okay, and then once you solve, your solution is either going to be written in the set brackets or x equals. Okay, and again, the domain is what you're putting in there, and then we're going to learn later about a range, which is going to be your y value, but we only have one variable right now. All right. So you might also see this E looking thing, and this is an operator for sets, and it just means that y belongs to that set. You might also see it written as is an element of. So it's just saying that y is an element of, or y belongs to that set. So it's just a thing that you're going to memorize about set operators. All right, so let's try another example. So again, now they're telling us the domain again. So they're telling us the value of y is somewhere in here. And we have to figure out which one of those numbers works. So once we replace y, we're trying to make that left side equal 3. So again, I'm going to do 4 different problems here until I can find the one that works. So if I go ahead and replace, sort of big here so you guys can see. So I'm going to put in a 0 for y, put the parentheses, and then 4 minus 0. So what do I do first here to simplify this one? Okay, I'm going to subtract. I'm going to do the grouping symbols. So 4 minus 0 is just 4. But then anything times 0 is what? 0. So does 0 equal 3? Okay, so this one is not a solution so far. So the 0 did not work. Now we're going to try replacing the 1. So 1, the grouping symbol, 4 minus 1. So I'll do the grouping symbol first. 4 minus 1 is 3. Multiply it by the 1. So then I get 3 equals 3. This one is a solution. And then just to demonstrate that the 2 and the 3 are probably not going to work, but let's go ahead and try them. So then 2, 4 minus 2, 2 times 2, 4 is not equal to 3, so that one's not a solution. And then again, I'm running out of room here, if I plug in the 3 parentheses, 4 minus 3, so 3 times 1, we have another one. So this one is a solution. Everybody with me on that? All right. So this is how you're going to do each one and try to figure out the solution by replacing and substituting and then following PEMDAS. Okay, the next one, it says to use that domain, 6, 8, and 12. And then the problem they're giving you is saying 5 more than twice a number is 29. What is the number? So again, they want you to do mental math. So I sort of left what you should have filled in. So 5 more than twice 6 is 29. So here, what is twice 6? Okay, and what's 5 more than that? Is that 29? Nope, so that one's gone. That doesn't work. Okay, we're going to do twice 8. Okay, plus 5. That one doesn't work. What's twice 12?
24.
Plus 5. And there's our magic one. So even if the problem is given to you in words, where you see the words a number, that's where you're going to replace the domain that's given to you. All right, let's look at some examples here. Now, notice we've got a really large domain here. So we're going to have to do 7 different problems here. And we're going to plug it in. And then if none of them work, you're going to say that it's no solution. Okay? But again, we're going to find a more efficient way. But for now, we're just practicing substituting in values. Okay? Again, remember, none of them may work. 1 may work. 2 may work. It'll vary. Okay? They all may work. All right? So for example, if we do number 1, what we need to do here is 7 different problems. So you're going to take the original one, the x plus 2 equals 6. The first time you do it, you're going to make x equal 0. So you're going to do 0 plus 2 equals 6. And we can see that that one doesn't work. Then you're going to do it again, and you're going to plug in 1. So then you'll do 1 plus 2 equals 6. 1 plus 2 is 3. And again, it doesn't equal 6. And you're going to keep repeating the process, replacing all 7 of these values. Make sense? All right, and then you just follow PEMDAS. All right, so let's see. Any idea what's going to happen when I try number 7? It's got x plus 4 and 4 plus x. Yes?
Since that is basically the commutative property of addition, additive commutative property. And so it would really be an infinite set.
Perfect. Okay, so when the 2 sides of the equation are equal, it's going to be infinitely many solutions. It's not going to matter what I put in there for x. It's always going to be the same number on both sides. Does that make sense? So notice when you put in the 0, 0 plus 4 is the same thing as 4 plus 0. They both give you 4. And then the same thing if you plugged in 1. 1 plus 4 is the same thing as 4 plus 1. And you get 5 either way. So essentially when both sides of the equation are the same, that's when you're going to see infinitely many solutions. Now if you notice on number 8, what do you think is going to happen there? Do you think any of them are going to work on number 8?
No.
Okay. Already you can see that over here is just the x, and on the left side you're adding 4 to it. So no matter which one of these you plug in, we're never going to get it to work. So this would be an example of no solution. Okay, so again, you're just going to write it all out. So you would do 0 plus 4. Does that equal 0? No, it doesn't. Plug in 1. You would get 5 equal 1, which it doesn't. So again, you're just going to have a lot of work on these problems. When you actually go to do your homework, they're only asking you to plug it in 6 numbers. Yes?
But when we write null set?
So what you would do is you're going to write no solution if it doesn't work. Now, some textbooks, when it's no solution, you'll see empty brackets with nothing in it, or you might even see a 0 with a slash.
We've been exposed to the 0 slash, which is null set.
Okay, so these are all examples of no solution or the null set, or in this case, the directions are telling you to write no solution. Okay, so just be aware that there's all different options out here. Okay, all right, yes?
So the variables, how they're set up in that problem number 8, no matter what number's there, it's always going to be no solution.
Yes. Does that make sense? And what they want you to do here, though, is to show it. Plug in all 7 of them. Question?
If you already know how to isolate the variable, can you do it that way?
Not yet. Okay, we're going to get there. So right now, we're going to get baby steps. And I know you probably have all already learned how to isolate the variable. by using inverse operations. But we're going to get there. Right now, they're just walking you through slowly. All right, so the course will pick up. I know this chapter is a bit of a review, but the course does pick up. It will get very challenging before Christmas. We will be doing factoring, which is probably going to be one of the hardest things you do in this class. You're going to use factoring the rest of your time in high school and probably in college. So when we get there, make sure you're paying close attention.